Okay. Nice to see you guys. Happy New Year for Neil. We haven't seen you yet this year. Nice to see you.
Oh yeah.
Quick agenda items. Mostly just if anybody's had a thought about things to do for next year since last meeting, feel free to share. Also, there's going to be a seminar next week. John Kadai is going to be presenting his MT stuff next week. I'm not quite sure on the time, but I'll get it up there and we'll get it announced as soon as we know more, but it'll be next week. Let's see. Quick report from me. I'm just finalizing a AG use, like a submission to the JGR Solid Earth stuff. I was going through like getting code up onto a GitHub repository, and it's for this. It's basically like doing clustering inversion on a electrical anisotropic layered half space. Just kind of playing with that. So either way, I have a solution that I'd like to get into SimPEG or to GeoAna as far as layered anisotropic electrical half space. Using the similar sort of thing. It's just a nice solution to have when we need it. Obviously, it works just fine for a isotropic half space because it's just a subset of it. But I'd like to get it in there, but it just requires a little bit more thinking on my part about how to get it efficiently in there to do the transformations, because right now the electrical anisotropic half space, you can't assume that it's going to be radially symmetric at all. And when it's layered, you can't really separate it between distance and angle. It's not really separable like that. So I right now it just does an FFT, which is like the catch-all thing to do for that kind of term, right? You do it in the wave number domain, FFT back to the space domain. But that is not very necessarily efficient. I was trying to figure out ways to do that using like kernels and filters and Dieter's MPy-mod. But I think it's going to have to be like a specially designed filter just for this problem. So I might have to play with that a little bit. Right now it is very inefficient, but I know it's inefficient and I know why it's inefficient. But it does it right now in a very, very accurate way, right? But it's unfortunate because it does like a whole 2D FFT for every single like data point offset. Instead of like, okay, if I've got a grid, if I've got like a sounding or something, it's like it needs to collect everything. Anyway, I know why it's inefficient, but I just need to figure out the best way to make it more efficient. Think about it a little bit, but it's a nice solution. It's a nice closed form or nice closed thing. It actually shows, and it's very easy the way so I hadn't seen it derived like this before in much of the literature. There's very, very similar derivations, but it highlights that in this case, like, you're only actually sensitive to an azimuthal anisotropy, even if it's fully anisotropic. You're only sensitive to like an effective azimuthal anisotropy.
Joe, I'm kind of lost, but are you deriving for D-series resistivity?
Yeah, for like a layered 1D half space.
Oh, like a layered model for D-series resistivity, and then you're expanding to anisotropy, like a vertical. Is that arbitrary anisotropy?
Arbitrary anisotropy in every layer.
That's pretty cool.
Yeah.
People have done that.
There's been a few small things here and there, but when I was trying to find all the like research, like they wrote it like all the derivations were in a way that like didn't feel right to me, or that it was not intuitive to look at what was happening. So like I had it, like I acknowledged them. I was like, writing stuff like this is all like equivalent and it's all consistent with what was done before. It's just I'm rewriting it in a way that is consistent with this work in this paper I'm presenting right now.
Cool. That's pretty cool.
But like I said, it highlights that there's all these different ways people have looked at anisotropy and electrical resistivity and soundings. So there's like the classic equivalent layer in a 1D model, right? For a isotropic half space, depending on, there's like a thickness and a conductivity quotient that you're kind of sensitive to, right? So that also comes out here in this, in the anisotropic one, but you also get this, that it's only sensitive to like an effective azimuthal anisotropy. And that basically that statement there encompasses a lot of what everyone else had like picked at, and like, oh, there's actually this equivalence for this certain case, this equivalence for this other certain case, what it all boils down to, they all have the same effective like azimuthal anisotropy. But that's anyway, I'd like to get into SimPEG, just a little toy. That's what I've been working on last week, is just getting the submission for the AGU with the GJR solid earth, because it requires, uploading all the code, making it open source. So it's a very interesting process, but paper's written, just doing the submission process.
Oh, cool. Yeah, I would love to actually have a read actually at one point.
Sure thing. I can list you as a suggested reviewer.
I think that's not a good approach. Internal network. It's not a good.
No. Anyway, so that's what I've been up to the last week or so. Any other updates over the week? Anyone?
After our conversation, Joe, I carried on. I went back and spent another hour on the new reg. It was all good. Everything you said made sense. So consolidate even more. Getting rid of the base regularization basically, and now the least squares regularization handles all of it. I haven't started PGI yet, but yeah, should be a lot cleaner. Hopefully spend more hours. And the big plan for me for this year, like I just had my my yearly work review, and we'll need to start bringing back stuff from our fork to main SimPEG, right? So that's probably going to be my year objective. Most has to do with the DASC module. But we'll need to come up with a more concrete plan, like we'll do it in phases, but make sure that we're all on par with each other. So yeah, that's my week and that's my plan.
Nice. So,
and we have over here is to start using trying to use PGI in Anger. So there might be some stuff that's coming, like as I start using that, maybe suggestions for improvements, modifications. So I'm interested to see what you're doing with the PGI side of things, Tom, when that comes around.
Have you started to work with that?
No, not yet. I did some. Yeah. I did a big handover with Thibaut.
Okay, good.
So I did some pretty extensive stuff with him over the last few weeks. But no, we haven't used it in Anger yet. But it is the plan, basically.
Yeah, I'm not going to touch any of the functionality. I'm just going to try to simplify it, because we're kind of try to consolidate some of the classes, clean things up, because things have like kind of ballooned out of control over time. So I'm not going to change at all what Thibaut wrote, other than just name changing and maybe all the classes tiny by structure, but not none of the mechanics. So we should not overlap too much. Yeah, but it would be good to have someone else hammering that part of the code. Yeah, pretty exciting.
Good. Yeah.
that's good. Yeah, one of the other things I want to work on this year is a little bit more on the cross gradient, and not cross gradient, like not just cross gradient, but also like the joint total variation, those other joint inversion methodologies that we've added. Like I kind of want to look at those a little bit more and provide more generalized use advice, I guess. Make them simpler to use, make them more effective. At least one of the things I want to try to work on this year, as well as, standard monitor everything that's going on. Devin, any updates? Soggy?
No, not really. I mean, I'm waist deep in some comprehensive workflow stuff for the sponsors. I guess the nice thing eventually down the line that'll come out of it is reproducing these things with SimPEG. So yeah, started out as a time domain EM project, but there's major susceptibility effects. So it's turned into a magnetics project. And yeah, it's keeping me busy. So I haven't really been able to get at doc strings and some of that stuff. It might be a while before I'm really involved in SimPEG.
Gotcha.
I guess for the year, we were talking about slowly pulling properties out, right? What's the status on that?
Yeah, so I think a few weeks, maybe before the Christmas break, we talked about an approach for exercising properties. We decided the best place to start was in the GeoAnna package. And I think I got the ball rolling on that and then got moved to working on other stuff. So I don't think it'll take too long once I have the time to work at that, but that's sort of where we are right now. And I guess discretize has already been depropertied. Once we have GeoAnna, then I'll go back into the SimPEG stuff. One of the things actually that I'm maybe would like to do over the course of the year, and I'm not sure it's really been put in, was that equivalent source layer inversion for mag. And for that project we did with the MDRU, I kind of made a branch, hacked something together to do what I wanted it to do, but didn't make a pull request and things. But that's something that would be very useful. And if we identify that as a pretty standard step in working through magnetic data, we should have that capability in SimPEG. Whether or not we want to make that some kind of property of our standard magnetic simulation, or whether or not we want to make some kind of equivalent source simulation class, that's something I think would be very useful to do.
Yeah, I got the feeling that its own class would make sense, like a subclass of the main one. Yeah, just because of the whole like active cells is not really a thing for that type of simulation. There's like setters that should probably be done differently. I think it would make sense to have like a 2D mag grav classes, right? That just do that.
Yeah, and that's a part of it. I mean, also, do you want one single layer? Do you want several layers? Because then I think the convergence happens a lot faster, even though you have more model more model parameters. It's kind of nice if maybe you can have like 3 cells thick, and then it just converges a lot faster than if you're trying to fit it with these really big, strangely shaped cells. Yeah, it just sounds like something we use pretty consistently. Some thought needs to be put in, but I'd like to have that in at some point. So maybe it's one of my projects for the following year, or for this year.
Lindsay, I see you popped in. I said there's going to be a seminar meeting next week. Not too much else. I don't know when.
I'll touch base with John. It will be next week. I think we'll do it on, we're usually doing them on Thursdays, right? That's what we've done in the past.
I think so.
Yeah, I'll see if that works with him. We'll plan for that. But then also just a quick note, if there's anything that anyone would like to have included in the newsletter, we'll try and get that out fairly quickly so that there's time on his announcement.
Sounds good.
So, but just on the excising properties, I was very happy when I heard that that was a thing that was happening in the project. When I first came across them, I'm like, oh, this is a pain. So it's good to see that it's getting removed.
Mhm.
It was made with good intentions, but it became overly complicated.
Okay, anything else? Not, I'm happy with the short meeting as always.
Yay.
Fine by me.
I see Soggy's name.
Yeah,
just got
Soggy's
hyped
got his
though.
thinking face on.
Today it's like we're talking about like what we want to do this year, right? Like that's the plan. Yeah, I have kind of a few thoughts. The main thing on my end, sort of finishing up the AEM stuff, at least solidify the 1D code, and then solidify the 3D code. So I have a separate branch that I worked for sort of 3D simulation for airborne EM, and breaking up the mesh in a slightly different way. Yeah, so I do need that because I am working on sort of separate project at Stanford combining head-logic process and then putting the EM data into that head-logic process, like a calibration process. So I think that's something that that I actually need to. So I want to make sure that's well integrated with the existing SimPEG version. And I think so that's just a pilot project that we're working on currently. So we're just testing like how the geophysical data can be integrated into their groundwater calibration process. But the bigger picture is actually kind of writing some sort of API that SimPEG, for instance, can be plugged in to PEST, for instance. So PEST is the optimization package that they typically use for groundwater modeling. So that could actually be huge because that means all of the groundwater modelers, well, not all, but some of the groundwater modelers, majority of the modelers that use the PEST to calibration can actually use the SimPEG readily and accessibly. So I think there are probably separate funding going to be generated. So potentially, I'm not sure I'm going to work on or somebody we're going to work on, but it seems like a pretty big potential. And there is a potential that we can work with who wrote the PEST. So yeah, I just it's a kind of big picture thinking and like where the SimPEG can fit in. And the other thing that I thought, I had a chat with Burke, and Burke Minsley is from USGS. So the big project that they are running is called what's called Earth MRI. And they are actually spending $300 million for the next 5 years to get the MAC data, and as well as the radiometric data and some of the geochemistry data. And there's no that 5-year plan is just collecting the data. So after 5 years, they have no plan, right? Like they don't exactly know how are they going to digest the data and then turn that into kind of a meaningful product. And there's no clear collaboration between like a USGS and the commercial sectors. So I think it seems like a lot of possibility how we can sort of think about how we can sort of further develop SimPEG in a way that can sort of utilize that data. I'm pretty sure that's going to be open sourced, and likely that should be in a pretty good readable form, in a digital form, I guess, that we can work together. But yeah, I'm just thinking, but my impression was working with the potential field geophysicists in USGS. They're very pessimistic about the potential field inversion. They don't use at all. So their typical product is just doing a reduced pole and then do a whole bunch of simulation. They just simulate the data and then see, it's more like a parametric types of inversion. So this seems like a challenge on our end, how kind of further develop the methodology or how to present the methodology in a way that can actually persuade those potential field people who are actually acquiring this data. So yeah, I think it's kind of a general big picture thinking. I'm not sure where to go, but it seems like good items to think about, and there's lots of potentials. And other thing, I asked Daniel Blatter, he's in Scripps. So he did his PhD with Kerry Key. So he's marine, but I think he's more like a mathematical geophysicist. And he's doing, I think what he's doing is quite cool. Like what he's doing, he started using the stochastic approach, like a Markov chain, Monte Carlo types of, like for 1D CSCM types of inversion problem. And then he's trying to extend his approach for kind of gradient-based inversion, but in a stochastic fashion. So what he's trying to do, he basically uses our regularizer as a sampler. So he's turning that regularizer as a kind of sampler. But what's actually cool, you don't have to do a Markov chain, but you can just sequentially sample. So you can massively parallelize that sampling process rather than kind of doing a one by one like a Markov chain style. So I asked him to give a talk in February. He said yes. So it's going to come. And I think there could be some interesting synergy. I guess his methodology quite kind of self-contained. And then plugging in SimPEG for his methodology and sort of see like what SimPEG inversion results look like using his methodology could be quite fun. And that could basically be applicable for a whole bunch of methodology that we have. So yeah, that seems like an interesting avenue and collaboration.
Did you, I think you posted something, right, recently? It was like,
yeah, I did kind of his AGU poster in like a,
right.
yeah, if you guys are interested, I'm not sure that's available, but yeah, he said he's going to give a talk, so I'll yeah, make sure advertise.
Yeah, it was neat. Is it just for the continental US that they're spending like hundreds of millions of dollars?
That's for critical minerals. So it's not everywhere in US, but the parts that they have some potential to have critical minerals like graphites. I think there's lithium, graphite. There are a couple other minerals
Okay.
focused on.
And they're going to do super high res radiometric mag.
Yes. So I have no idea how the radiometric data is interpreted, but this is something. If there's some sort of inversion is related, I think it's a potential that we probably need to develop, I guess, and be ready to digest those like huge data.
Sounds good.
Sagi, is that something Burke is heavily involved in?
Not Burke. I think Burke is kind of in an odd position. Although he's in the mineral sectors, but yeah, his funding is most coming from water. So I think Burke is not necessarily heavily involved. So I think, and also the EM and MT is not a big kind of part of that Earth MRI project. So I think the kind of recognition in EM is pretty low in their minerals and metal sector in USGS. So that's another challenge that we have.
Right. Yeah. Because one thing that twigged, and maybe there's actually a couple talks here, but it'd be great actually at some point to get Burke to give us a SimPEG seminar if he's game to. And if there is an avenue to make a connection with somebody who's involved in that project, if they want to give a talk, that might be a nice way to make an initial connection, but I don't know who that would.
Right. I think that Leon Fox could be potential. I think he's the actual developer of that GeoBiPi that Burke is doing. So I think he's more like a computational engineer guy writing codes and stuff like that. So and actually he changed the 1D code at some point. He actually wrote the Fortran code. Which Joe made much more improvement, but he also made a bit of improvement from my rudimentary Python code. So it'll be interesting to bring him and ask him to give a talk. So Daniel's talk, I guess, he wouldn't talk about the SimPEG at all, which is probably a little bit different from other talks, but I think it's fine, I guess.
It
can also be about, hosting people doing open source stuff as well, and whatever projects we find interesting. So reminds me, I should send a text to Leon. Chat with him every once in a while. Okay, sounds good. Well, Lindsay, as soon as we know time, we'll get that announcement out. Add your stuff to the newsletter, any information. If not, we'll see you guys next week or 2 weeks. Oh, one other thing. I think on next Friday, I'd like to do an afternoon coding session thing where we kind of just go through, maybe just look at go through a state of SimPEG PRs, pull requests, bugs, stuff like that, like we've done in the past sometimes. So if you guys are good to do that Friday afternoon, have a drink, come on by.
This Friday.
Next Friday. Sorry, next Friday.
All right. Sounds good. I'm getting my booster shot, so if I'm not too sick, I'll come.
Oh.
Okay, see you guys.
Take care.